Okay, so now let's look at a couple of questions. First one, find the parametric equation for the line in which the plane is given here. Okay, so how do we work on this? Well, the brief idea here is, if you have one plane here, and then there is another plane, intersect with each other. Of course, those two, we can claim that this is the intersection line here. Well, it turns out that the normal vector. Let's see if this is the first plane, the P1. This is P2. So the normal vector for P1 here, if we denote it as N1 here, and then the normal vector for P2, if we denote it as L2 here, and then turns out that those two, you can see that if you do a cross product here, and then the resulting vector will be the parallel vector to this intersection line. So that's where it starts. So given to this problem, you can see that if normal vector for the plane P1 is going to be 2, -6, and 3, right? And then in 2 is going to be 1, -2, and 2 here. So if we do a cross product, let's see, N1 cross N2, that will be I, J, K, 2, -6, 3, 1, -2, 2 here. Okay, so once you finish this, turns out what you're going to get here is this is -12 minus, right? Minus, this is -6 I, right? And then for here it's a 2 times 2 minus 1 times 3. So give us is +1, but it's minus. For here is 4 minus 3 K, and then plus, this is -4, right? There's a minus -6. Oh, excuse me. This is J. So this is K. Okay. So if you simplify, what are you gonna get? Here is -6I, right? So minus J, and then this is minus become plus. This is plus 2K here. So E vector is -6, -1, and 2. Okay. So once we have that, this is going to be the vector that is parallel to this line of intersection. So the next thing, so to find the equation of line, what do we need here is we need a parallel vector, which we just calculated, and also we need a point on the line, right? Okay. So how do we handle that? Well, it turns out that to figure out a point on the intersecting lines is not that bad. Why? Because since both those two planes, and then those are not either parallel to any of the x, y, and z plane. So in other words, the intersection line here, since it's infinity, and then definitely it will intersect to a point on the xy plane, yz plane, or xz plane. So if we can set the z coordinates equal to 0 here, and then turns out you can solve the 2x minus 6y equals 12, and x minus 2y equals 6. Those are the pairs of equations here. So it turns out you see that you can see if we claim this is 1, this is 2. So we let 1 minus 2 times 2, because here if you times 2 it can become into 2x. So that will give us is 2x minus 6y equals 12 minus 2x minus 4y equals 12. So if you do a subtraction, you can see 2x minus 2x becomes 0. 2x minus minus 4y this part becoming to negative 2y equals 0. Turns out y also equals 0. Okay. When y equals 0, you can easily solve that x equals 6. So you can see that the point of this intersecting is 6, 0, and 0. So now we get a point, we got a parallel vector. So the parametric equations is going to be xt equals 6 plus, well, it's going to be minus 6t, right? Yt becomes into 0 minus t. Zt becomes into 0 here plus 2t, and t is from negative infinity to positive infinity. So we finished this problem.